Hi everyone, and welcome to this PD on how to use Autodesk Inventor. In this we'll be creating a little keyring sort of thumb piano, which should be quite a fun thing to make. And to start off with, I've got a fresh install here of Inventor 2021. Little caveat here, I have not actually used 2021 yet. It's just come out and I've just installed it. So when you install Inventor, you'll see the same thing that I'm seeing here. You're presented with a Start Learning and a Start Working page. This Start Learning thing is full of really nice tips on how to navigate the Inventor menus and such like. That's really nice. We're going to jump into Start Working as I talk you through things. Now there's several different bits you can see here. These make up the things that you can do with Inventor. You can create a part, you can create an assembly, you can create a drawing, and you can create a presentation. Now, all these have different purposes. What we'll be starting off with is by creating an assembly. Now, your parts go into your assemblies, and then you have drawings, and the drawings can be of individual parts, or the drawings can be of assemblies. The drawings are the things that you'd send to an engineer to have ticked off or as working drawings. That's what you create there. We won't be doing that in this tutorial. I might cover that in a future tutorial. Presentations are a more advanced version of this drawing, and that's where you can do things like exploded diagrams. Yeah, IKEA is great at those exploded diagrams of how things go together. So we'll start off by clicking on Assembly and load up one of those. All right, here we are in our working environment. So this is, as I said, this is brand new to me. I've not done 2021 before, so if I stumble across a couple of things, we'll discover everything together. Now the first thing we need to do in this assembly is to create a new part. There's a bunch of different types of parts that you can create. We're just looking for a standard.ipt at the moment. Obviously you can create parts that are made for sheet metal. Now those are great if you're doing anything to do with a laser cutter or a plasma cutter, anything that can cut sheet metal. We've got the standard IAM. Now a standard IAM is a sub-assembly. So if you think about it as in terms of a bicycle, you might have the pedal attached to the crank, and then you'll have the chain rings, the cogs on the front, which are attached to that crank, and the whole thing then attaches to the frame. Now that pedal and crank assembly is a sub-assembly that makes up the full assembly of the bicycle. So a standard IPT is what we'll be creating, and then you've got a weldment, which is another type of sub-assembly. And a weldment, if you think of something like maybe a dual suspension mountain bike, a weldment might make up the back half of the frame or the front half of the frame in those two separate bits, and maybe the fork would be a separate weldment. That's a welded assembly. So we'll go to our standard IPT. Now we'll create our part, and now we want to make sure we name everything. If you leave things as they're part 1, part 2, part 3, later on it can get a little bit confusing. So we'll call this one the body of our assembly. And in this case, it's just saving in my regular documents folder. I'm going to put that into its own separate folder. Now you can see there's plenty of folders here. I really like to keep everything organized. Each project gets its own folder. And that's really important with Inventor, is that you keep everything together, because an assembly is exactly what it says. It's an assembly of parts. So if you have a if you have a part that goes missing in a wrong place, that will also go missing from your assembly. Now in here I've got my Inventor Online folder, and I've got my body IPT. We'll save that one there. And click OK. So now it's asking here for select sketch plane for base feature. Now the base feature is obviously the first part that you make. Everything else is built in relation to this in the assembly. So what I want to do here is I'll go over, this is the first time you create a part, you have to do this. So we're going to origin, and then we've got a bunch of these different planes. Now we've got the X, Y, and Z directions, and each one of these planes is made up of 2 of those. So I think we'll click X, Y for our initial sketch. Now, to create a part, first you create a sketch, and then you create what's called a feature from that sketch. So here we have a 2D sketch. You can select a 3D sketch. They're quite complicated, and we won't be covering that in this tutorial. Again, I might look at covering those in a future tutorial. 2D sketches. So here we have our different planes. They are down the bottom there. It's a little bit hard to see, but they do say, I think that one is ZX, ZY, and there's a bunch of different ones there. We'll click the flat one. So we've now gone from a 3D environment into a 2D environment. And we can do things, we can create rectangles. I'll get rid of that one. For our little thumb piano, I think I do want to create it as a piano type shape. So what I'll do is I will create a rectangle, and we'll make the rectangle point base here, 0, 0. Now, being an American bit of software, it's coming up and it's asking me for 0 inches and 0 inches. I would much rather work in metric. Makes a lot more sense. So we'll come up to here and manage. It's been a little while since I've had to do this one. Tools, I believe. And then there's document settings here. Now you can do this individually. There's also a way of converting the whole thing for the whole program, rather than every document having to work with a separate part. So go from document settings, units, and now we can select our millimeters as our units. The reason it's got time and mass and everything else here is that you can also use this to work out the mass of items using the various materials that are in here. Again, it's part of the very powerful features that Inventor has. We'll apply those settings, and then we can close that window. So now when we go back to our Sketch tab and select a rectangle, we're now being asked for the size in millimeters. And that's a really good thing for me to show you, because Inventor does default to imperial measurements, despite the fact that there's only one country in the world that actually uses imperial measurements. Now what we're creating here is a keyring. So what I can do is initially, I've got some sizes here, and I can just click really anywhere and create something that's roughly the right size, because Inventor is what we call a parametric program. And that allows us to change our sizes later. And every size is dependent on every other size. So here I've got a 20 millimeter square. I reckon 20 millimeters is probably a little bit small. I mean, I don't mind having a big keyring piano for this one. So I'm going to make this one 35 millimeters. And you can see how it's changed here, that second dimension. Interestingly enough, I'm getting these sort of artifacts on there, which indicates that this isn't 100% flat. So if I start another line, it's just a way to check this. So when you specify a line, I can say that I want this line to be, for instance, 20 millimeters long. And if I press the tab, that allows me to change the degrees. I want this one to be 90 degrees. And I can just double check, then escape, and escape ends that line. So I can check the dimension between this line here and this line here, and if they're not parallel, it'll come up with an angle measurement. So here it's come up with 9.23, and that's a distance measurement, which means that they are parallel. So I'm just getting some strange artifacts on my screen, and that's everything's okay. But if you come up with that sort of thing, then that's a really nice little way just to double check. And we'll select that and delete that because we don't need it. Now, if I put a second dimension on here, I've got this one to be 35. But if I want this dimension to be dependent on the other dimension, then what I can do is, like you're doing a formula in Excel, you can put in equals, and then I can click this dimension here, and then I can say times 1.5. And what that means is that this dimension will always be 1.5 times the length of this dimension. So say I think, oh, actually 35 millimeters is far too big for a keyring. I'm going to make it back to 20 again. You'll see that this dimension here will always be that 1.5 times that dimension. Revert that one. Great, so I've now got a square, but a square's got some pretty sharp edges, and it's not very interesting a shape for our little keyring. Remember, this is the body. This is what everything is going to be based around. So what I can do here is I can go up to our line tool, I can go down, and I've got spline. Now a spline allows me to do some really cool curves. So you'll note that the little marker here has gone green, and green means that it's snapped to some sort of feature. In this case, it's snapped to the corner of those lines. Now I think I actually want to make my little thumb piano look like just a small piano. So I'll come to about halfway down there, and then I'll bring my spline down, and you can see that what's happening here is that it's creating a line kind of interpolated between those points. And I think we'll go something like that. So we're creating a vaguely sort of grand piano shape keyring. Now you can go back later and you can edit these. So I think I do want to bring that one in a little bit, a bit more curvature in there. Now it won't let me move this one, because when I put this one on the line, it was directly on the midpoint of that line. And so there's a resistance on there to stop that. If you don't want a spline to be locked in like that, you can just click somewhere else. The other thing you can do, this is getting a little bit advanced for this tutorial, but you can go down here and you can say, usually, I may have wrecked myself, that's okay. There is a way to show what's called the constraints, and these constraints here will pop up, and you can delete the constraints that are holding that in place. But in this case, I'm happy enough with that. So what I'll do now is I will trim this line. So you can see here that when I wave my cursor over here, I've got a dotted line and I've got a solid line. Now if I put my cursor down here, the dotted line is on this part, and now the dotted line is the bit that's going to disappear. So I'm going to trim that section of the curve. What's going on there? What I might have to do, these dimensions can sometimes stop other things happening. So sometimes it's worth just deleting them. And, oh no, it did trim. Tell a lie, it did trim. It was just that it trimmed and left behind the guideline, which confused me a bit there. So then we'll delete that line there. And now we've got a shape that's made up of these lines. And I want to maintain those dimensions. So here I'll add the dimension back to this one. Happy with that. And we'll add this dimension back here. Now, this dimension, because I deleted it and reinstated it, that is now set at 52.5 millimeters in length. It's no longer the 1.5 that it was. I can quite easily recreate that, that formula in there if I want to. Excellent. Now, just before I do the next stage and create this as a feature, I think I do want to put a bit of a curve on here. So I can go into here and use fillet. And now the radius of my fillet is this measurement here. Here we go, so there's radius 2 millimeters. So what I might do is create that as something a little bit bigger. I think I might like 5 millimeters as my radius. And then I'll click on the first line and the second line. Is it going to let me do the second line? It may not. That's okay. Because that second line is a spline, it's got some more complicated computing to work it out. And sometimes it won't let you do things like fillets onto there. But that's not a problem because we can do that at a later stage. It's a great thing about Inventor. There's actually several ways of doing everything. So I finished my sketch and we're back into a 3D environment. So what I can do is I've now got a bunch of 3D modeling options for my sketch. I'm going to extrude it. Now, for my little keyring piano, I think 10 millimeters is probably about the right height. And it looks, again, vaguely piano-ish. So I'm okay with that. I've got my profile selected. It's extruding from the sketch plane. And I've got the direction. So I can extrude it up or down or both directions. Or I can do an unequal extrude, where I can extrude 10 millimeters in one direction and 5 millimeters in the other. We'll go with the first one. Great. So now we've got our little keyring piano. But if this is going to be in your pocket, you'll note that you've got some sharp edges here, and look, probably these ones too, that we want to smooth off a bit so we don't get attacked by our keyring. So what we can do is now do that same fillet function, but we can do that as a 3D tool. So we've got a radius of 2 millimeters. Again, I'll make that 5. And now we've got select our little lines that we want. So instead of selecting one line and then the other line like we did in 2 dimensions, in 3 dimensions, we just select the edge that we want to fillet. So that's that one there. And you can see we've created a nice little edge. And I'll also fillet this edge here. I think that edge is a little bit too big. So I'll cancel that. And we'll come back here and we will create a 5 millimeter edge here. We'll apply that. That's fine. I like that curve. This one was took a bit too much off that corner and I lost that shape. So I can change that radius back to 2 millimeters. And there we go. That's a better shape. And I can apply that one. Now, for these corners here, I can do the same thing. Let's click that one there and that one. And we'll apply that. Now that still leaves us with this edge here and this edge here. We'll probably address those later because I do want to do some more on those faces. But the great thing about Inventor is that you can do something and you can turn it off and then you can come back to it. So what we'll do is 2 millimeter radius, that's okay. So you can see I'm selecting that entire edge. And we'll apply that one and then cancel to exit out of that. So we've now got something that's got some nice smooth corners and will hopefully not dig into your skin too much. Excellent. Now what I want to do here is I want to hollow this shape out to create that hollow piano effect. Because we can 3D print this, and a 3D printed shape, especially if it's printed in something like ABS or high impact polystyrene, actually resonates quite well. So to hollow that out, all I need to do is go up to this tool called Shell, click that one, and we can select we can remove the faces that we want to remove, and we can set the thickness. So the face I want to remove is this top face, and I think there we go, select that one. That was already selected. So I'm removing that face, And now I've got a nice hollow shape here that's going to be 1 millimeter. Now to get some really good resonance, I might actually hollow that out to 0.5 millimeters. So we'll make it really thin, which will make it a bit weak, but hopefully those rounded corners will give it the strength that it needs. Now if I decide that, actually, look, 0.5, I'm just not comfortable, I think that's going to cause problems. This is where I've got my little menus on the side here, and you can go back and edit anything. So if I right click on Shell, I've got the options to repeat, or I can go down here and I can edit the feature. So by editing the feature, I can say, look, let's split the difference, and let's say we actually want that to be 0.75 millimeters. Just a little bit thicker to give me the confidence of, maybe if it gets hit by my keys or something. There we go. Great. So we've now got the hollow body of our little thumb piano. Got nowhere for the keys to go or anything yet, so we can do that with another operation. What I might do is I'll end this as the first part of the tutorial, and we'll address the rest of it in the next part.